So let's try to see if we can answer some few questions there. This is under linear motion. It was saying figure 1.1 shows the velocity time graph of a car on a journey. So you can see the velocity time graph, and they've given us the letters PQRS. Then it says state what was happening to the velocity or at the points labeled PQ. So at the point PQ, the velocity was constant, so we can simply say constant velocity. So the velocity was constant, meaning that it was not actually accelerating. In fact, that velocity is maintained at 18 meters per second. Then at RS, you can see it decelerates. Then there, it simply means that the velocity is actually stationary. We can simply say it is actually stationary. So it is actually stationary, meaning that the velocity has gone back to 0, 8 meters per second. So that is what is happening. So the object or the car is not actually moving at that point. No wonder it is actually stationary. Calculate the distance traveled. So if you notice, that forms up a trapezium. The whole shape is a trapezium. So distance is equal to the area under the shape, which is a trapezium, given by half a plus b multiplied by h. So therefore the distance will be 1/2. Remember, a is the smallest distance between the two parallel sides. From here to there, that's my a, which is equal to 5. And from here all the way up to here, this is representing our b, which is 15. And the distance or the between the two parallel sides is the height, which is equal to 18. So therefore my a will be 5 plus 15 plus I multiply by 18 outside. So 2 there, 1, 2 there is 9. And if you add 5 plus that will give me 20 times 9. And 20 times 9 will give me 180 meters. So the distance was 180 meters that it traveled. Then it says, by how much did the motorist decelerate between Q and R? So they want the deceleration. So the deceleration, we use the same formula, which is final minus initial divided by time. So now he starts to decelerate at that point. So what's the velocity? The initial velocity is 18. Then when he reaches at R, the velocity will be 0. But the time taken to move from Q to R, you say 15 minus 10, which will give you 5. So therefore, the final velocity is 0 minus the initial, which is 18, divided by the time taken to decelerate, which is 5. So it will be, in this case, negative 18 divided by 5. And therefore, if we replace it use a calculator there, so that will be negative 18 divided by 5. And that is going to give us negative 3.6 meters per second squared. So the deceleration in essence is 3.6 meters per second squared. So that negative is simply telling you that it is slowing down, but you can still include it there. There's no problem. Let's come to this question. It was actually on density. It says figure 2.1 shows the power of 10 glass slides, each of length 10 centimeters and width 3 centimeters. The POW had a height of 10 millimeters. Take note of that. And the mass of each slide was 5.4 grams. So if you look at that, they have given us the length, which is 10 centimeters, the breadth or width is 3 centimeters, and they have also given us the height, which is equal to 10 millimeters. So if you notice, the 10 millimeters is actually different. So how do I convert in this case? So remember, 1 centimeter is equal to 10 millimeters. So if you are converting there, you are simply dividing just by 10, which is going to give you 1 centimeter. So now with that in mind, because you have worked on that one, what is the volume of the power? So the volume is given by L times B times the height. So the volume will be the length, which is 10 centimeters, times the breadth, which is 3 centimeters, times the height, which is 1 centimeter. So when we multiply that, it will give us 30 cubic centimeters. So the volume is simply 30 cubic centimeter. I hope that's okay. Then it says, what is the volume of one glass slide? Since this is the volume of the 10 glass slides that we have, we can find, volume. So we can say volume of one, glass slide. So it will be equal to the total volume, which is 30 cubic centimeter. You divide by how many they are. And when we divide that, it will give us 3 cubic centimeter. So 3 cubic centimeter is actually the volume of one glass pile. Then let's come to this one. It says, what is the density of the pile? So if you notice, they gave us the mass, which was 5.4 grams. This was for one. So now if you want to find the total mass, since it says what is the density of the whole pile, so we need to find the total mass of the pile, which will be the mass of one, which is 5.2. We multiply by how many they are, which will give us 54 grams. And remember, we know the volume of the whole pile, which is equal to 30 cubic centimeter. So we can find density is equal to mass divided by volume. And therefore, if you look at that, the mass is 54 grams divided by the volume, which is 30 cubic centimeter. So we can calculate that 54 divided by 30, and that is going to give us 1.8. So our rho P will be 1.8 gram per cubic centimeter. If you wanted to give it in kg per cubic, just multiply this by 1000, which is going to be 1800 kg per cubic meters. Okay, so the density is 1.8 gram per cubic centimeter. Where did I get that? Remember, 1 gram per cubic centimeter is equal to 1000 kg per cubic meter. So this is the conversion that you can use to convert between gram per cubic centimeter and kg per cubic meter. Thank you so much for watching. Watch out for my other videos.